Perfect. Welcome, everyone. I hope you can all see my screen. If not, please let me, Sam or Jeff know. So this is the external synergies for Rubin Community Science session, and it is organized by Jeff Newman, Sam Schmidt, and myself. You can see here the session webpage, and there are some videos that you can also see there, describing some of the synergies that people thought were mentioning, and also describing the surveys that we're looking at all together. If you would like to upload a video yourself about your thoughts, there's an opportunity to do so as well. Just send the video to one of the organizers, and we will make sure that it reaches this webpage as well. We have a Slack channel that you've already, that I hope you're already part of, and let's get started. So some friendly reminders to begin with. You all abide by the code of conduct during registration. The code of conduct is very easy to be found. Main website, resources, and then you're right there. So just to recap, we adhere to the principles of kindness, trust, respect, diversity, and inclusion in order to provide a learning environment that produces rigor and excellence. And discriminatory gender identity, national, political affiliation, age, marital status, sexual orientation, disabilities, or any other reason will not be tolerated. And so if you witness something like this, any form of bullying or harassment or aggression, please follow the reporting instructions at the code of conduct. Some other friendly reminders. So all of the talks of this workshop will be recorded. Given that we have a panel discussion, that will be recorded. Videos are going to be posted the next working day. So you are encouraged, of course, to give thumbs up on Slack to show your appreciation on Slack, and also in the chat, of course, through the various applause buttons. I mentioned already that we have some preview content. So there's videos and slides, Space Telescope, Euclid, DESI, CMB experiments, and on the external synergies to Rubin. You can see all of that here. That's the link to our webpage. These slides will provide some background on the survey capabilities, but they also outline some synergies already as have been identified speakers there. And again, you're encouraged to share your thoughts there. We will collect them. We will make them publicly available. So if you want to record a short video, it's very easy to do via Zoom. 5 minutes, 10 minutes, please send it to us and we will post it. The session is organized as follows. So we have in the Slack channel, we have a couple questions that you can upvote or downvote, and the voting can still continue right now. So this is being monitored. And if something, if a new question arises, or if one of the existing questions gets a very, very strong boost, we already have 5 questions, but if one of the ones that we do not have gets a strong boost, we will of course ask that as well. So important here, really, this is supposed to be interactive. You can add your own question. You can use the chat. You can use the Slack channel. It is all monitored, and we will ask those questions as they arise. If there are some questions that we don't have time to address during the live session, we will do our best to respond on Slack during the week. So we hope that this discussion will continue on Slack during the week. And with that, I have the honor to introduce our distinguished panel. And we thought we would just go around the room. So if everybody who is mentioned here, starting with David, could quickly explain their background. What is the connection to Rubin Observatory? What is the science collaboration? What is the science background? And also, which projects are you involved in, and which synergies are you most interested in? David, please take it away.
Hi, can you hear me?
Yes.
Yes, good. So I'm David Alonso. I work at Oxford. I'm part of the Rubin Observatory I'm mostly interested in the dark energy science collaboration. I'm also part of the Simons Observatory. So I work kind of in between large scale structure and CMB data analysis. And those are my 2 main interests.
Renee.
Hi, folks. I'm Renee Hlozek. I am at the University of Toronto in the Dunlap Institute. And similar to David, actually, I have 2 interests, complementary interests. Within the Rubin Observatory, I'm part of the Dark Energy Science Collaboration. My science interests there focus mainly actually on kind of supernova cosmology, but I'm also Deputy Analysis Coordinator for DESC. But I'm interested more broadly in cosmology questions that are also answerable with the CMB. And so I'm also part of the Science Observatory as is David. And I'm interested in the kinds of cross-correlation science that we can do to probe cosmology using both probes.
Alexi?
Hi, I'm Alexi Liotta from UCSC, and I'm currently working in the Hypersupreme lensing survey, as well as in the DESI collaboration. In DESI, I co-chair a working group called Cross-Correlations, Clusters, and Small-Scale Cosmology. So in particular, there's going to be a lot of synergies between DESI and Rubin. To mention a few, there's going to be joint analyses of lensing plus clustering. There'll also be calibration of photoz's via cross-correlations with DESI galaxies. And then could also imagine synergies in terms of clusters where DESI provides redshifts for cluster members, just to mention a few.
Dan Masters?
Hi everyone, I'm Dan Masters. I'm actually at IPAC at Caltech now. I'm a Euclid member. I work with the PhotoZ team for Euclid, leading a survey to get spectroscopic redshifts to meet the bias requirement. I also now work at the Euclid NASA Science Center at IPAC as a pipeline scientist developing the GRISM pipeline. I'm a member of the SphereX science team, and I also work 50% of my time on the SphereX pipeline development at IPAC at the SphereX Data Science Center. And I'm a member of the Roman Cosmology Science Investigation Team led by Olivier Doré. And so a lot of my interests have to do with galaxy evolution and how are we going to measure photometric redshifts for these missions.
Thank you. Peter?
Hello, I'm Peter Melchior. I'm largely interested in big surveys. I'm involved in LSST and I work with the DM people a lot, and but I'm also in desk. Other than that, I work on say putting fibers, allocating fibers for PFS. I'm part of the new Roman Science Interest Group that kind of invites contributions from the community on how to use Roman. And my science background is largely in weak lensing and statistical inference.
Thank you.
I'm Michael Troxel at Duke University. Within Rubin, I am part of the Dark Energy Science Collaboration. Outside of Rubin, I work on the Dark Energy Survey, and I'm part of the High Latitude Survey Cosmology Science Investigation Team with the Roman Space Telescope. My interests are mostly in large-scale structure and weak lensing cosmology, and in particular for Roman, I focus on validating weak lensing methodology with pixel level simulations of the survey.
All right, thank you everyone. So with that, I think we should jump right into our first question. So the first question is on simulations, and I'll just quickly read it for everybody to digest, and then we'll go around the room and of the panel, and please just share your thoughts that you have, and hopefully that will trigger some discussion. So simulations, what sort of simulations would be needed to jointly interpret data from your survey and Rubin data? Do those simulations exist? Are they planned? Or is this an unmet criteria, an unmet need? If somebody wants to go right ahead, perfect.
So for Roman and other space surveys, I can say that there is an existing dark energy science collaboration project to produce mirrored matched pixel level image simulations between Rubin and Roman right now. And test simulation of about 4 square degrees exists for that to enable studies of joint pixel level analysis. We hope to continue producing more realistic and larger simulations like that. But currently that work is funded through the HLS sit with Roman.
For ground-based CMB stuff, I think the main type of simulations we would likely use is kind of joint large-scale structure simulations, looking at the same patch of the sky with correlated, galaxies and CMB secondary anisotropies. I think the main uses for this would be things like covariances, looking at CMB lensing biases in the cross correlations, and I could imagine extragalactic foreground contamination as well as being one of the things we would use it for, and also to develop joint pipelines between the different collaborations. It might be that there's a lot of information in hydrosims that would be useful for to model things like like SZ cross correlations, things like that. But those are available anyway. That's not something that needs to be coordinated, I think.
So from the DESI perspective, my experience is that the simulation needs to be considered jointly with the specific science case at hand. So it's hard to say exactly what sims are needed unless we're make it clear what science goal we're talking about exactly. This has been clear in C-Cube, the working group that I co-chair, because depending on exactly which science question we're talking about, we have different sim requirements. Generally speaking, the sims we use are simulations for emulators and for covariance estimation. In DESI, we have, we're using the Emulus simulations as well as the Abacus simulations run by Daniel Eisenstein's group. But it would need to be considered further whether or not those sims would meet the requirements for this science case.
If I might quickly ask, which science case were you referring to specifically?
Well, so that was my point. I think there's multiple science cases we could consider joint between Rubin and DESI, and depending exactly which science case we're talking about, the simulation needs would be different, whether it's clusters or DNDZ or lensing plus clustering. So I think one would really need to sit down and identify the key science cases and then have the simulation requirements flow from there.
More comments on simulations, perhaps?
I just wanted to say for Spherex. Yeah, for Spherex, one of the big issues is measuring redshifts using the near-infrared spectrum of a galaxy at like R of 40. So one thing that concerns me there is, do we have the models extending out to 5 microns that'll let us do that confidently? I don't think we necessarily do at the moment, so that's something we need to think about.
Yeah, for PFS, I think we run into similar issues. I think a lot of what Alexei just said and what Dan said resonates with needs we have on the PFS side. The level of detail in the simulation is, or the level of realism of those simulations is questionable. So you can use the same light cone, but you still get a simulation of the spectral properties that may or may not be good enough for what you want to do. It needs to be the same light cone for any joint analysis. I think that's clear. But and so it's good that we have that on the imaging side now with the Roman simulations and LSST-like simulations. But on the spectroscopy side, there's a lot of physics that would have to go in that we don't fully understand.
Yeah, I would echo that. Even in the image simulations, there's a limitation to the realism of the infrared part and the visual part of the spectrum as it maps into the band passes, which may be a problem for actually using it for science analysis as it is now.
So one question that always comes up in context of simulations is like separability of simulations for the different systematic studies, for example, right? For some, you of course need imaging simulations, for others you don't necessarily. Covariance matrices, you might need something very different than if you were to test your pipeline at super high accuracy. Wide surveys need something else than small scale cluster surveys that need higher resolution. Where do you see these fault lines coming? Or what is a useful separation? Because we probably can't generate an enormous amount of simulations of the high resolution, super large box sizes, all the way processed to imaging.
Yeah, I think it comes back to what I was saying earlier about the requirements are very closely tied to the particular science goal. So I think the way to go about it would be to sit down and name the 5 key cross-correlation studies that we think are going to be key, and then think about the requirements from there, because depending on the science, sometimes you need more high resolution, sometimes you need wider and lower resolution, sometimes you might want hydrosims and together with that. So it's sort of hard to generally just say what the SIMS requirements are.
Right. One way maybe to break this up is to say that one set of simulations is actually meant to validate algorithms, in which case the exact level of realism isn't really that important, because you can set out to get something that you would like to get back. So you start with a simulation where you control everything at the level you need it to. And that can be a relatively small simulation. It just needs to be very, very accurate. And then on the other hand, you measure what you came to measure and see whether you can do it. And so just to validate that process, you don't need tons of data, but you need to be very, you need to be sure that your simulation is good enough and precise enough. So that is one set of simulations. And then there's the big set of simulations where you try to match the universe the best way you can. And that is where realism comes in, but that may not, or at least not in all cases, require the same level of detail as validation simulations do.
As an overall feeling, do people think that it is more or less on track with the simulation effort, or that the plan is yet inherent and not well defined, for example, as a function of science cases, as Alexei said, or as a function of algorithms?
I think at least from the CMB side, we are having meetings, joint meetings with a bunch of different logical structure groups to at least figure out the small subset that Alexei was talking about. That doesn't mean it's done, but at least I think we're trying to scope it out. And I'd be curious if there are similar cross collaboration meetings, longer ones planned, with the same thought as this meeting itself, to define those subsets, or if they're basically reliant on individual groups in individual collaborations.
So from the DESI side, we haven't really interacted a lot with other surveys right now. We're in touch with a few CMB surveys, but there's no DESI cross LSST thought working group. So we have not thought deeply at all about these issues. I think that would be a really useful thing to do, but it just hasn't been initiated yet.
All right, so there's clearly room for improvement in terms of coordination and even just getting started with some of the efforts. So maybe we should move on to question number 2. So data sets we're discussing have widely varying data structures, for example, imaging versus spectroscopy, and also very different resolution. I mean, there's obviously space and ground. There's lower resolution for spherics and CMB experiments. So what are the best ways to enable joint analyses, or just to enable joint catalogs to incorporate these various different types of information? Part, this is a question also about formats, but general strategies, how to enable these joint analyses.
Yeah, I think I can take that. The way we've approached this in various different aspects of it is to assume that you can formulate a model that describes all of the data sets, and that basically is high enough resolution that everything that is an observation is actually downgraded, meaning that if you have a high and a low resolution imager, which is the combination of Roman or Euclid with LSST, then your internal model needs to have high enough a resolution that you can downgrade from where you are, from this internal model to any of the observations. And that's like, this is not something new. This is just, this has been done for a long time in order to match different resolutions. But expressing this in a fast way makes it relatively challenging. Resampling operations, for instance, are expensive to do. And so this is more an operational problem to make it such that it is not insanely expensive, and not a conceptual problem. If you want to do this also with spectroscopy, then it becomes really challenging, because now your internal model needs to have the full spatial and spectroscopic coverage that any of your observations can have. And that becomes a much bigger block. And it might be very hard to constrain all of the elements, all of the moving parts of that model with the available observations, specifically if you have, say, one that has high spectral resolution and one that has 0 spectral resolution and is only kind of spatially resolved. So a good instrument to bridge the gap is a GRISM, moderate spectral resolution and some spatial resolution. So it really is a question, can you nail down all of the moving parts that an internal model needs to have, such that you can formulate a joint model for all of these observations?
At least for CMB, I think we've found that the approach that Peter just mentioned at the beginning works quite well. At least when we've thought about synergy with Rubin, in terms of, as long as Rubin is able to store its huge data on some pixelization scheme from which it's easy to then create the maps at the right resolution that we need for CMB, then it's fine. And actually, tools have have been developed in order to do that. So that works quite well for maps. The other aspect, I guess, on a lower level would be things like cluster catalogs and things like that, making sure that the data is in the, that we know what the data should be to be ingested by likelihoods and things like that. And that requires some early talks within collaborations to make sure that we understand what the different likelihoods assume about the contents of that data. But I think that's a much easier problem to solve.
So in terms of the actual measurements, I know in SphereX we're planning to do force photometry. So we'll be using higher resolution data to identify where the galaxies are, what their shapes are, and so on. And because we have an undersampled PSF and large pixels, it'll be really important to have that information from external surveys. So that's one area where Rubin can really help SphereX, for example. I think a flip side of that is that for a particular Rubin galaxy, you won't have a good SphereX spectrum. But what you could imagine doing is, for a big sample of tens of thousands of Rubin galaxies that are similar, you could stack the SphereX spectra for them and get sort of an ensemble average for what does that look like, because you have so much statistical power in the SphereX data set.
For DESI, I think most of the analyses will be done at the catalog level. So for DESI cross Rubin, I don't think data format is necessarily going to be the largest issue. Instead, similar to what David, I think coordinating on likelihoods and simulations and mock challenges will be more of a key issue.
If I may ask quickly, in terms of force photometry for SphereX, is the idea to process the entire Rubin data jointly with the SphereX data?
No, it wouldn't be done at the pixel level. We would assume that we have a catalog of astrometry and maybe some basic shape measurements available from Rubin and other surveys. And those would be used to set the force positions for the SphereX photometry and the shapes of the galaxies.
Any other comments on data sets, data structures? So in terms of the likelihood interfaces, perhaps quickly, is there sufficient crosstalk across the collaborations such that you're confident that joint analyses will be possible once the individual Cs have been done?
At least within the CMB community and interfacing largely with the desk. For Rubin, we are working together to try and make sure that our interfaces are compatible, making sure we're using the same data formats like SAC, and eventually moving to very similar sampling codes. So we're working quite closely together. And
I think part of the reason for that is the fact that there's been a lot of overlap in the members of both communities. So there's a lot of simultaneously people who are very interested in desk, and we've been involved in both of them at the same time. Otherwise, I think it's harder to develop this kind of stuff.
So it happened.
Sorry. I was just going to ask a question because I don't know. There are no actual agreements between these missions at the moment to do any joint pixel level processing. Is that correct? Okay. I guess probably not.
No idea. Sorry. Troxel, you were saying something.
I was just going to say that there's also a lot of overlap between Rubin and Roman, and while the preliminary data formats and processing standards for Roman that have been put together are largely consistent with what would need to happen to be compatible with Rubin, it's too early for any of the processing and analysis pipelines to have been written. That won't happen until the next SIT, which will be in a year or two.
I think there are some plans between Euclid and Rubin that have gone to a more concrete stage for coordinated analysis. I think that's been mentioned in other forums.
There is a working group to discuss derived data products between the two missions, but I don't think that there's been a commitment that joint pixel level processing will necessarily happen. But I assume that would be an output of this discussion with the joint derived data products working group between Rubin and Euclid.
Yeah, I think that nothing has been, since this group has only been founded, nothing has been actually decided. But it is within the scope of that group to recommend that such joint analysis could be done. It's not the question who is actually doing it and how exactly, but if there's a scientific need or if there's a benefit in doing so, then it would be kind of in the purview of that group to make a recommendation.
And data is going to be public at some point. So then it's just free for all. All right, perhaps we should move on to question 3, except for if there's any other questions related to data sets, formats. I don't see anything in the chat, but yeah. All right, so question number 3, what obstacles have you encountered in the past when trying to undertake joint analyses or collaborative efforts across multiple projects? So that refers to Rubin cross something, but also, of course, to precursor surveys. So how can we improve the situation for Rubin in the future?
I think one thing we've seen is sometimes there's some stiffness in the external collaborator or the publication policies that maybe prevents you from actually doing something that you want to do and that the other collaboration wants to do, and you have to figure out that you're not breaking your own rules in order to be able to do that. So I think putting some thought on that in advance is good, and I think that's probably something easy to do once the data is there and everyone's very urgently wanting to analyze it. But if you can do that in advance, that's better because you'll be able to develop pipelines and things with some time. The other thing I could think of is maybe if you don't have a complete understanding, or at least a good understanding of what the science requirements are for the other collaborations, sometimes you may start developing things that are not going to work for any joint analysis with them. So as I said before, I think having an overlap between the people that are working in both is a good idea. So that you know, there's expertise on both sides. Yeah.
One of the things we currently encounter when we try to combine HSC precursor data and HST data in the Cosmos field is that the astrometric solutions aren't good enough to actually allow us to do that. Coordination that could happen, and I think would make everyone's life a lot easier, is if there's a coordination at the level that defines a common astrometric grid. Whoever defines that, or however it's defined, but adopting a common one would be beneficial. That's not as simple as it sounds, because not every survey sees the same stars in the same way. It's sometimes stars also move. That doesn't help. So their moving objects are interesting because they break some of the assumptions that one makes about stability of the, among other things, the astrometric solution. But finding enough overlap stars that one can tie to the same astrometric grid would help us a lot. And currently we have to offset, putting in code to offset every single element from HST with respect to where officially the HSC position should be, because then they don't match up quite well. Photometric standardization is the same story, just now for kind of how you count photons. That's also not trivial. So if you wanted to make an SED fit through all the channels you have available with multiple surveys, that's also not trivial. And temporal aspects are also kind of an issue. So when you observe something and it's moving and you have enough spatial resolution to see it moving, then you need to do something about the movement. Gaia will help a lot for everything that is bright enough for Gaia to get peculiar motion. So these are kind of low-level things that should happen if one wanted to do specifically pixel-level analyses. Catalog-level analysis are somewhat mitigated by that. I said about photometry still applies, for instance.
So in my experience, things that have been challenged in the past are when combining two data sets in cross-correlation are often differences in analyses choices and tools that are used. So for example, differences in where the covariances come from, how the likelihood is generated, the scales that are used, and choices that are made for marginalizing over nuisance parameters. So there are certain science cases where putting things into place early can be useful. In particular, a lot of that early work relates to testing things on simulations and having the required fields in those simulations. So I think overall, for me, a key thing would be to have science cases identified and early discussions between two collaborations on the things that are needed to be put into place to do that science.
Yeah, a related issue that we found is that some surveys have different systematics. And so you're at the mercy of combining data sets that each have their own systematic levels and sources.
Yeah, that's a really good point. And then that ties back to the simulation effort, because when you do the mock challenges in the beginning, you'd like to have ideas of how those systematics impact your results. And so you really need to do that simulation work early with an understanding of the systematics that you expect for each of the two data sets.
Does that make a joint effort an entirely new endeavor?
In some cases it might, in some cases it might not. I think it depends on the science case at hand. To give some examples for combining lensing and clustering, you know, we're doing mock challenges right now in the context of DESI, but we're assuming, you know, current lensing error bars, not Rubin error bars. So if we wanted to do that Rubin, we probably should redo that effort with smaller error bars, for example. But there are other science cases where it may be much more straightforward. For example, knowing spectroscopic redshifts for cluster members, there may be less things to be put into place in that regard.
More comments, experiences to share on joint endeavors?
Yeah, this is Siegfried Egger speaking. We had like a very interesting discussion with Euclid in terms of solar system collaboration between Rubin ops and Euclid observations. And one thing that came up was different timescales of data publication. So for instance, if we were to try to get data as early as possible, so our science case, for instance, is to have a joint characterization in terms of photometry, some filters of Euclid for solar system objects that are complementary to what the Variance Rubin Observatory would give us. And sometimes Variance Rubin timescales are quite fast, so especially if you have alerts that are triggered. And I'm not sure if there's anything equivalent at the moment considered for Euclid, if there are Euclid alerts going on. And the same issues with the data release catalog. So sometimes, you know, for moving objects especially, it's relevant to get them fast before they move out of range again. And this was a challenge actually, and it still is a challenge. We tried to find a way around that.
Maybe Dan can chime in on the observing strategy of Euclid. Is there something like an alert?
No, not that I'm aware of.
Okay, then I think we should move on unless there's any more comments on joint endeavors. I mean, or on obstacles related to joint endeavors. I guess we will experience several of them. So it's good to identify them early on and try to mitigate them. This is a new question, I guess. I don't know.
Yes, a question from Slack.
Okay, perfect. So there's additional scientific potential in combining Roman and Rubin observations of the galactic bulge by coordinating Rubin observations of the Roman galactic exoplanet survey region. Okay, can the organizers comment on the potential here? So Roman and Rubin joint observations of the galactic bulge.
So there is a microlensing survey planned for Roman, which will take up some number of months each year of the 5-year reference survey plan that focuses on the galactic bulge to identify exoplanets. That will be repeated imaging. I'm not an expert on the microlensing survey design, so I can't say much more than that, but it will be a large fraction of the Roman data that comes out of the planned legacy surveys that would be available. It will certainly not have the same cadence or requirements in terms of coverage that the wide field HLS survey does. So beyond galactic bulge studies, the data would perhaps not be suitable for other studies.
So there is potential in combining, if the Rubin Observatory schedule is adapted suitably, then you can extend the time series quite dramatically and as well improve the results of the Roman galactic bulge survey. So there is a fair amount of galactic science that comes out of that. And I think it will require the coordination of the observing strategies. Now for Rubin, of course, the observing window is quite fixed. So, sorry, the Roman window is quite fixed. And so this would need to be taken into account in the Rubin observing strategy. But the potential, I think, is extremely broad for galactic science.
May I just, this is Marc Monnier, may I just add just a short comment? This is, in my opinion, this is strongly connected with the alert system of the Rubin Observatory. So it's more a question of dynamic interaction than interaction between data sets, I think.
So does that require communication, like live communication at the time? Is that what you're saying? Or is it
Yes.
just, okay.
Yes.
More comments on these synergies?
It's in terms of time-sensitive overlaps of data taking, which I think is part of what we're talking about here. There will be a process in the next year or three where there's a broader community discussion about the legacy surveys that Roman will pursue and how they're formatted, the requirements on them and things. And so that would be a good engagement opportunity for ensuring consistency in these science cases across the two observatories.
So if I can ask a related question, does the Roman Observatory plan an alert system similar to that of Rubin? And if so, what's the timescale on which alerts would be made public?
I don't know the answer to that.
I can chip in from the point of view. Oh. Go ahead.
That's okay.
I just wanted to say, from the point of view of the Roman microlensing SIT, there has been some discussion of having alerts from Roman possibly within 24 hours, but I don't believe it is currently within scope.
Is that a problem?
So one of the things we're planning to, part of the discussions of future support to science teams is going to include discussions about supporting teams to do things more broadly than exoplanet studies and cosmology, and it's quite possible that a team specifically to look at transient and alert systems across all the surveys might be a reasonable thing for us to consider in the future. The reason we can't be more specific at the moment is that we haven't yet decided or planned precisely what the structure of the future science support to the Roman community is going to be. But it's flexible, and certainly some of us are thinking along the lines that we are going to need to have more coordinated work on alert systems.
All right, thank you. Moving on to question number 4. For joint analyses, how much independent analysis do we want to do before combining? Famous problem. Are there concerns about potential systematics propagating to multiple surveys by tying everything together too early? Can we mitigate those concerns with systematics tests, cross correlations, etc.? And I perhaps would like to add that there is value in having multiple independent analyses going on to check for results. So how do you balance that with the power of a joint analysis and the need for preparing for this early on?
I guess to come to this a little bit, I think, it's definitely good. We should enable joint analysis and cross correlations, but I think you only really start to worry when particular choices about, the values of parameters or intrinsic, and systematic uncertainties are decided by the joint group. And I think we should avoid that. So we should make it, easy for folks to do the analyses and build those pipelines early, but there should be still independent choices made about data cuts and selection effects and systematics. Those should, I think, be defined first by the individual collaborations and then have another subset which are specific to the cross correlations.
I think there are some cases, sorry, again.
No, go ahead.
I was going to say there are obvious cases where having independent pipelines is critical. For example, the lensing shape catalogs, Rubin should be independent. There's a great deal of value there. Other aspects would be building up cluster catalogs. I think there's a lot of value in having independent ways of constructing cluster catalogs. But then there are other topics where there's only one real way of doing it. For example, if you're going to derive redshifts using cross correlations with DESI, there's probably only one sample there to use. So they're, I think, working early on together on improving or testing the photos through cross correlations is an aspect where there's probably only going to be one way forward to do that cross correlation. So in that regard, I think early collaboration is better for some things and independent pipelines is better for other.
Yeah, along the same lines, I would say that there's a practical approach here, and that is that most of the surveys will do their independent analysis first, and having those as a not as a backdrop, but as a cross-check of what you do in a joint analysis, I think is incredibly valuable. So just from an operational perspective, I don't think there is that much of a conflict. There's always a conflict because you combine those things or you combine multiple surveys together. And now if there's some systematic creeping in from any of the sides, then you would contaminate the joint result and you don't exactly know where this is coming from. But I think this should be visible in the comparisons of the individual surveys that are obtained without combining them. That's true for some of the science cases that can be done independently, but as Alexi just said, there are some where this is much harder to actually do because the independent analysis doesn't really exist. But anyway, I think that we will have the independent analysis no matter what, even if we think about a joint analysis.
Do people agree with this? Is this going to be a truly independent analysis, or does this need to be enforced in some shape or form? Or do you think there is just going to be secrecy between the major collaborations that is sufficient in that regard to ensure that they're really independent?
What exactly is really fully independent? I mean, there's overlap on the sky, for instance. So you work with the same objects. There's you might work with the same pipeline or some at least agreed upon procedure of analyzing the data. So independence is it's not a black and white thing. It comes in shades. I think what we're talking about here is whether there is an individual analysis that was completely independent and then maybe only combined at the likelihood level, where you have to worry about maybe whether the surveys overlapped on the sky, and so whether they're truly independent in that sense. Anything below that, I think, is always somewhat correlated. They're not fully independent. I don't think this can be made.
Also, looking at some of the comments on the right-hand side, we need to recognize there's more and more overlap between people who work in multiple surveys. And so that does go against independence. And I think there's going to be more and more overlap, for example, between people who do lensing and who are working in these different surveys, and ideas propagate. And maybe in the end, everyone ends up using Medi-Cal, for example. So I think it's something that needs to be thought about seriously.
I was specifically worried about implementation, to be honest. I mean, of course, ideas are highly correlated, right? There's clearly leading ideas in aspects of the analysis, but in terms of implementation, if I mean that their independence is of value. Yeah. Okay. I see we've gotten lots of questions, so I'm going to move on. Chris Walter, there are many discussions here and elsewhere of joint work and coordination between two projects. What is the danger that choices used in these bilateral plans might sometimes be inconsistent with each other? Is there motivation to try to have a wider discussion for these choices that encompass the multiple projects so as to allow multiple combinations and also avoid duplicated work? Duplicated work. I think this relates nicely to what we've just been discussing. So are there some plans for wider discussion that we're aware of, other than, for example, the DDP working group?
I mean, so just to follow up, you hear a lot about, you know, Euclid, Roman, or people working between Roman and Rubin, vice versa, but or Sphere X and Euclid. But if all those people are working independently, you could easily make choices that make it not possible to put three of them together, and you might have to wind up going back and re-implementing a lot of things. So this kind of discussion that's happening here for the first time, I think, is useful, and I think people should keep that in mind, even if it's only at kind of a high level, almost API type discussion.
Any comments on the worries that we might be duplicating too much work?
I'm not sure that duplicated work is a bad thing.
I think as long as you have the people power to do it, that's good. But we should also sometimes acknowledge that we don't have often as many people working on something that we need as we would like to. I think so. Yeah.
I think I'm less concerned about duplication than I am about ignoring some science. Sorry.
Oh, please, Rachel, go on. Sorry, if you want to repeat.
I think there's a delay on my end, so I apologize if I overspeak someone, but I'm less concerned about duplicating effort in coordinating these great observatories than I am about the potential for focusing on some science areas, but ignoring the scientific potential of bringing other people to the table.
The duplication part, I think, is at some level, I think, inevitable. And on the other hand, it also provides independence. So it ties into the conversation we just had before about at least the implementations are different. And even if the ideas are very similar to each other. So independence, I think, is a good argument for why every survey should have their own pipeline to the degree possible. What I think is more challenging is the question of, if you want to combine them, how much of these codes can you reuse? Or do you want to reuse? And so that, I think, is a bigger question. But I don't think that the individual surveys should feel somehow restrained from doing what they think is best.
So Peter, just to be clear, I think people are missing the sort of gist of my question. So I actually don't think we should be sharing a lot of software tools. And I personally think the analysis should all be done independently first. I mean, that I didn't speak up before, but so I think that's actually important. What I'm talking about here is, like, for example, we've now stood up this committee that you're on and Troxel and other people are on, which is the Euclid Rubin derived data products committee, right? Which will somehow eventually allow us to do work between Rubin and Euclid. And at the same time, you might have the people from Euclid or Roman talking to the people from Sphere X. And as somebody pointed out earlier in the discussion, you know, combining things is not trivial. You make analysis choices inside each collaboration, right? So if the people, if LSST, or sorry, if Rubin decides working with Euclid to make a certain set of choices, that might not be consistent with the choices that Euclid needs with Sphere X. And the duplication I'm talking about here is, especially if one does joint pixel processing, there's a lot of going back that you might have to do depending on the selection choices that you made. So the sort of thinking behind my question was not about what we do in the individual in the individual collaborations, but in the individual projects, but rather in the context where you want to combine things together, making sure you only don't do it in a bilateral one-to-one way, but thinking about it in a larger way, because really there's something like 5 or 6 projects that in the end might need to be working together. And if they've all individually made 6 different agreements with one other person, then that's not efficient. That's what I meant. And you could somehow wind up in a situation where you've made a lot of choices, then you wind up having to go back and reproduce data sets for 5 different selection criteria to make it work with every different person.
Okay, does somebody want to take this quickly? Or intermediately?
I see your worries, and I don't see an easy mechanism to avoid at least some amount of reprocessing in a joint analysis. As I said before, if we could standardize for pixel level processing, we would have to standardize, for instance, the astrometric grid. And that's not obvious that that can be done, or how well this can be done, even if it is attempted. And so I'm not sure it could be done in a way that is very smooth and streamlined, and doesn't incorporate or doesn't involve having to reprocess some of the surveys to tie them to other surveys.
All right, so I think this is going to be the last question that we have. A unique aspect of LSST is the many real-time alerts that will result. Have there been any good examples of real-time coordination across surveys that we could try to emulate? Examples in the past? Perhaps with ZTF, I don't know.
There are historical examples in the microlensing for this. So we have those good examples.
What is the what was the intent of the word coordination in this question? Coordination of observations?
Observations, targets, timing that you observe particular fields.
So one thing I can say about Rubin is that we plan to publish our detailed observing plans at least 2 hours in advance, and possibly farther than that, using a community standard protocol that's being developed by the IVOA.
So we have a comment on the chat from Matthew Graham that people can look at the growth efforts for LIGO follow-up using ZTF and DCAM. I don't know if you want to say a little more about that.
I can. It's just that, I mean, there is, although ZTF doesn't do broad coordination of all the hundreds of thousands of alerts we put out every night, with the LIGO and some of the GRB alerts that come out, there are groups who try and do dedicated follow-up programs, and the Growth Consortium led by Mansi Kasliwal certainly has been, they established a consortium of, I think it's 16 or 17 different facilities around the world to try and capture follow-up activities or coordinate follow-up activities, and they've certainly done that with a LIGO trigger comes out. It's then figured out which set of facilities can be used to observe and which ones are going to go for it. Primarily, it's ZTF and primarily it's ZTF and DECAM because they're the ones which have the largest field of view to cover the LIGO error circles. But there is certainly an international coordinated effort on that through a specific program. Now, I think what you would anticipate potentially with LSST is that the alerts for specific subcategories of science are the ones where you might try and coordinate. I don't think you can do a broad coordination right across the science, but I think individual science consortia might determine that with a subset of facilities they believe they have available to them, that they can do some coordination.
Thank you. These are definitely good examples. Unfortunately, we are at the hour, so I think we have to close this session. I would like to thank our panel and all the other people who contributed very much. And I hope we've all taken this as a starting point for future interactions and for developing future thoughts for synergies and joint analyses. Thank you, everybody.
I will say that we'll try, if we didn't get to all the questions, we will continue the discussion on Slack over the course of the PCW meeting here. So if we didn't get to your questions, apologies, but we'll try and answer them. Panelists or others, anyone can chime in. We can continue the whole discussion on Slack.